Hello dear students, welcome to the lecture 1 of Artificial Intelligence and Machine Learning courses. Let's start. Lecture 1, Introduction. Based on Assistant Professor Dr. Senem Kumova Metin's resources.
Dictionary definitions of intelligence.
So, let's take a look at the definitions of intelligence written in different resources.
The ability to use memory, knowledge, experience, understanding, reasoning, imagination and judgment in order to solve problems and adapt to new situations. The ability to learn or understand or to deal with new or difficult situations. The capacity for understanding. Ability to perceive and comprehend meaning. The ability to acquire and apply knowledge and skills.
Okay, as you can see, there are 4 main descriptions of intelligence.
Overview of artificial intelligence, AI. Computers with the ability to mimic or duplicate the functions of the human brain. The term was coined in 1956 by John McCarthy at the Massachusetts Institute of Technology.
So, it was invented, the term of artificial intelligence was invented in 1956. You see, the history of artificial intelligence goes so back. However, only recently it is becoming very popular. Do you know why? Because of the advancing uh, libraries and the hardware. We will see them in the future lessons, what I mean. But its root goes back to till 1956, which makes roughly 64 years. It is so old. So there are two main definitions made for artificial intelligence. Artificial intelligence systems.
The people, procedures, hardware, software, data, and knowledge needed to develop computer systems and machines that demonstrate the characteristics of intelligence.
So to compose an artificial intelligence system, we need all of these, and we need to put them in together, use all of them in the needed way. Okay.
Overview of artificial intelligence, AI.
So let's define intelligent behavior. So what do we expect?
Learn from experience, apply knowledge acquired from experience, handle complex situations, solve problems when important information is missing, determine what is important, react quickly and correctly to a new situation, understand visual images, process and manipulate symbols, be creative and imaginative, use heuristics.
So all of these are aspects or features of intelligent behavior.
Design methodology and goals. The exciting new effort to make computers things, machine with minds, in the full and literal sense.
So some of the goals that people have put in the previous years.
The study of mental faculties through the use of computational models. The art of creating machines that perform functions that require intelligence when performed by people.
I think this is very, very accurate. You know, a robot can do non-changing things, such as a robot can cut a metal always in the same way. This wouldn't be an artificial intelligence. For example, a robotic car factory. In a robotic car factory, there are multiple robots work in synchronization and builds a car, but it is not result of an artificial intelligence because they are programmed to do certain things and it is just repetitive. It doesn't require intelligence when performed by people because you always cut the same line, cut the same way, cut the same dimensions. It is robotic behavior but not an artificial intelligent behavior or the intelligent behavior.
A field of study that seeks to explain and emulate intelligent behavior in terms of computational processes. Systems that think like humans, systems that think rationally, systems that act like humans, systems that act rationally.
Okay, let's start with
Systems that act like humans. Behaviorist approach. Not interested in how you get results, just the similarity to what human results are. Eliza, one of the first chatterbots and one of the first programs capable of attempting the Turing test. Turing test, a test for intelligence in a computer, requiring that a human being should be unable to distinguish the machine from another human being by using the replies to questions put to both. 6.
okay, 6 extra read it. Okay, so Turing test is extremely popular in terms of artificial intelligence. Let's learn more about the Turing test.
Acting humanly. The Turing test. Alan Turing's 1950 article Computing Machinery and Intelligence discussed conditions for considering a machine to be intelligent.
So, in such an environment where uh, there is a person asks both sides questions and get the answers. One side is real human, one side is the machine. So, if the interrogator, the person who is asking the questions, cannot understand the difference between human and the machine, it passes the Turing test.
Interrogator asks questions of two people who are out of sight and hearing. One is a human, the other one a machine. 30 minutes to ask whatever he wants. To determine only through questions and answers which is which. If the interrogator cannot distinguish between human and computer, the machine has passed the test.
Currently, I think this is still not possible. You can ask such a questions to determine which side is human or computer. So, for computer to pass this test, computer needs to possess these skills.
Computer needs to possess natural language processing, knowledge representation, automated reasoning, machine learning.
Okay, let's see what does each of them means.
What would a computer need to pass the Turing test? Natural language processing. To communicate with examiner.
So it has to understand the question. It has to convert that into the text and into the meaningful queries to answer it as a voice again. Natural language processing.
Knowledge representation. To store and retrieve information provided before or during interrogation.
Okay.
Automated reasoning. To use the stored information to answer questions and to draw new conclusions. Machine learning. To adapt to new circumstances and to detect and extrapolate patterns.
Okay, so the computer may have, let's say the integrator asks 100 questions and the computer knows 99 of them previously coded. However, if a new question comes that the computer doesn't know programmatically from before, it needs machine learning to answer that new question. Okay, problems.
Problems. 1. Turing test is not reproducible, constructive, and amenable to mathematic analysis. 2. What about physical interaction with interrogator and environment?
Okay, so what does this means? Uh, each time the Turing test would change each time according to the person asking questions. So you cannot reproduce it or test on it. So you have to have a system that is general as much as possible, and in that way it would answer every person questions if it is being general. And what about physical interaction?
Total, full, Turing test. Requires physical interaction and needs perception and actuation.
So what does this mean? Let's say I ask it, let's say there is a window that we can put objects. I said that, and let's say I have two pencils. I am putting there two of my pencils, and I am saying the uh, side, the other side, take my blue pencil and leave my red pencil. In order to pass this test, the computer has to be able to see the environment and act with it with the like an human. Like it must have an arm, robotic arm to get that blue pencil, red pencil, and leave the other one. Okay.
Computer needs to possess natural language processing, knowledge representation, automated reasoning, R, machine learning, Mr. and computer vision, robotics.
So computer vision and robotics would be required to do such physical tasks. These are needed to just talk and answer, but these are needed to do physical tasks. So
What would a computer need to pass the full Turing test?
it needs all of these.
Natural language processing, knowledge representation, automated reasoning, R, machine learning, Mr. Vision, to recognize the examiner's actions and various objects presented by the examiner. Robotics, to manipulate objects and move about.
So with vision, we recognize our environment and take an action according to that. And with robotics, we manipulate the objects, do physical things. Systems that think like humans. Okay.
Focus not just on behavior and I/O, look at reasoning process.
What does this mean, do you think? This means that we are not just focused on behavior and input-output. It is more about the reasoning. When a human takes an action, there is a reasoning behind it. Okay, that's important.
Computational model should reflect how results were obtained. GPS, general problem solver, goal not just to produce human-like behavior, like Eliza, but to produce a sequence of steps of the reasoning process that was similar to the steps followed by a person in solving the same task.
So I have, let's say, your manager has given to you a task, and to solve that, you need to make some planning, take step-by-step actions. In an artificial intelligence system, we expect the same.
Thinking humanly, cognitive science. Thinking like a human, determining how humans think. Cognitive science brings together theories and experimental evidence to model internal activities of the brain.
So the aim of cognitive science is uh, using the same model of our brain. You know that our brain is composed by synapses and the interactions and the roads between them. So with the cognitive science, we are trying to uh, compose a system works in a way similar to our brain.
Systems that think rationally. Formalize the reasoning process, producing a system that contains logical inference mechanisms that are provably correct, and guarantee finding an optimal solution. This brings up the question, how do we represent information that will allow us to do inferences?
So we have to, one of the hardest things in the artificial intelligence is that representing the information to the machines. So how do we represent, let's say, a bag in the room to the computer? As a human, our visioning capabilities are extremely superior, but we have to represent that object in the computer way so that computer can process it, analyze it, and take actions on it. Represent the data representation is one of the hardest part of uh, computer AI. We will learn more about that in the future lessons.
Thinking rationally, laws of thought. Aristotle, 450 BC, attempted to codify, right thinking, what are correct arguments, thought processes. E.g., Socrates is a man, all men are mortal, therefore Socrates is mortal. The law of thought approach initiated the field called logic.
Okay, problems. First,
1. Uncertainty. Not all facts are certain, e.g., the flight might be delayed. It is not easy to take informal knowledge and state in formal terms required by logical notation, particularly when the knowledge is less than 100% certain.
okay, the second one is
Resource limitations. Not enough time to compute, process, insufficient memory, disk, etc., etc.
okay. So resource limitation was a very big problem until recently. It is why the AI is having a blast nowadays. You see, it was founded in 1956. It was invented as a word. However, it is recently becoming very popular. Why? Because only the recent developments of existing libraries, frameworks, and the computer hardware and the data we have, it only recently allows artificial intelligence to uh, become some reality, become stronger, better. So this is one of the biggest limitation, resources limitation. Systems that act rationally. So these are the rational systems.
For a given set of inputs, tries to generate an appropriate output that is not necessarily correct but gets the job done. Rational and sufficient, satisfying methods, not optimal.
So you probably heard act rationally. Act rationally, what does that mean? That means that we try to achieve uh, we try to achieve a success. We try to achieve solve a problem. It doesn't have to be the best way. It doesn't have to be the optimal way. But our aim when acting rationally is getting as much as the benefit. Okay.
Acting rationally. The rational agent approach. Rational behavior. Doing the right thing. The right thing, that which is expected to maximize the expected return, provides the most general view of AI because it includes correct inference, laws of thought, uncertainty handling, resource limitation considerations, e.g., reflex versus deliberation, cognitive skills, NLP, R, knowledge representation, ML, etc.
So NLP is natural language processing. R is uh, what was it? Automated reasoning and okay, and knowledge representation and machine learning and such things. Advantages. More general, its goal of rationality is well defined. So the goal is to maximize the expected return. Okay, maximize the expected return. So maximize the benefit of our aim.
Acting rationally. The rational agent approach. An agent is something that acts. A computer agent is a program that operates under autonomous control, perceives the environment, persists over a prolonged time period, adapts to change, is capable of taking another's goal.
So this is the features of a computer agent.
A rational agent is the agent that acts so as to achieve best outcome or when there is uncertainty the best expected outcome.
So this is the goal of the agent. Why study AI? AI is the next step of the, the development of human mankind. You know, the robotic age, I mean, the machines uh, has made us progress only so far. Now we can produce cars, better cars, or we can produce much more food and live in much more luxury, all due to machines working without ever stopping. However, AI will get us the next step. I believe that in some future that humans will not be have to work at all. There will be universal income for everyone and everyone will live without ever working. Everything that has to be done by humans will be done by machines. This is my somewhat prediction of the far future.
Applications of AI. Game-playing Deep Blue chess program beat world champion Garry Kasparov.
Now this is much more advanced. For example, even in now real-time strategy games such as uh, Dota 2, it's a very complex game. It's a very hard game. AI can now beat even such that game. It is already very hard game for a human team, but AI is now capable of beating the humans in a such game. Let's see some more information about that. Okay.
At OpenAI, we've used the multiplayer video game Dota 2 as a research platform for general-purpose AI systems. Our Dota 2 AI, called OpenAI 5, learned by playing over 10,000 years of games against itself. It demonstrated the ability to achieve expert-level performance, learn human-AI cooperation, and operate at internet scale.
So you see, this word is very important. General purpose AI systems. General purpose is one of the aims of AI. If you have a specific task, you don't need AI. You can code it. You can program it with ifs and elses and switch cases and such things. However, if you want something to be general purpose, you need AI. Okay, and let's see if there is more information. Okay, you can search for more information about this. Speech recognition. I use speech recognition to generate automated subtitles to these videos by using Google Cloud. And this is also another thing of AI, text to speech.
Pegasus Spoken Language Interface to American Airlines EAASY Sabre Reservation System, which allows users to obtain flight information and make reservations over the telephone. The 1990s has seen significant advances in speech recognition so that limited systems are now successful.
As you can see, it speaks, however, it is still not as good as humans. Yes, it is still clear that it is spoken by a computer. But I believe in future it will become much more advanced and human-like. Computer vision, which is used in many areas, such as autonomous cars or collecting fruits from vegetables, from plants.
Face recognition programs in use by banks, government, etc. The ALVINN system from CMU autonomously drove a van from Washington, D.C. to San Diego, all but 52 of 2,849 miles, averaging 63 miles per hour day and night, and in all weather conditions. Handwriting recognition, electronics and manufacturing inspection, photo interpretation, baggage inspection, reverse engineering to automatically construct a 3D geometric model.
Okay, applications of AI, expert systems. So what is an expert system? Let's see it.
Application-specific systems that rely on obtaining the knowledge of human experts in an area and programming that knowledge into a system.
Okay, for example, Let's look at the Wikipedia. Expert system, let's read it.
In artificial intelligence, an expert system is a computer system that emulates the decision-making ability of a human expert. 1. Expert systems are designed to solve complex problems by reasoning through bodies of knowledge, represented mainly as if-then rules rather than through conventional procedural code. 2. The first expert systems were created in the 1970s and then proliferated in the 1980s. 3. Expert systems were among the first truly successful forms of artificial intelligence, AI, software. 4, 5, 6, 7, 8. An expert system is divided into two subsystems, the inference engine and the knowledge base. The knowledge base represents facts and rules. The inference engine applies the rules to the known facts to deduce new facts. Inference engines can also include explanation and debugging abilities.
Okay, there are some history, advantages, disadvantages, applications. Also, let's see. Okay, this looks like a good one. Okay, for example, let's read it. You will get more information.
Example number 1. Mycin. Historically, the Mycin system played a major role in stimulating research interest in rule-based expert systems. Mycin is an expert system for diagnosing and recommending treatment of bacterial infections of the blood, such as meningitis and bacteremia. It was developed at Stanford University in California, USA, in the 1970s, and has become a template for many similar rule-based systems. It is intended to support clinicians in the early diagnosis and treatment of meningitis, which can be fatal if not treated in time. Advertisements. However, the laboratory tests for these conditions take several days to be completed, so doctors and therefore Mycin have to make decisions with incomplete information associated with medical knowledge. Mycin incorporated a calculus of uncertainty called certainty factors which seemed, at that time, to fit well with how doctors assessed the impact of evidence on the diagnosis. This system was able to perform as well as some experts and considerably better than junior doctors. A consultation with Mycin begins with requests for routine information such as age, medical history and so on, programming to more specific questions as required. Mycin's expertise knowledge lies in the domain of bacterial infections. Mycin's pool of knowledge consists of approximately 500 antecedent consequent rules, implemented in Lisp which give Mycin the ability to recognize about 100 causes of bacterial infections. Physicians usually begin antibiotic treatment for patients who have bacterial infections without knowing exactly which organism is the culprit. There is no time to wait for definitive laboratory culture evidence, which accumulates too slowly. For the desperately sick, therapy must begin at once, not 2 days after. This requirement leaves two choices. The physician can either prescribe a broad-spectrum drug which covers all possibilities, or he can prescribe a better, disease-specific drug. Mycin helps the physician to prescribe disease-specific drugs. Mycin informs itself about particular cases by requesting information from the physician about a patient's symptoms, general condition, history, and laboratory test results. At each point, the question Mycin asks is determined by Mycin's current hypothesis and the answer to all previous questions. Thus, the questions start as though taken from a checklist, but the questions then vary as evidence builds.
Okay, so this is an expert system. Why? It focuses on one goal, determining the bacterial information cause. It is the which infection, which bacteria. So this is a system expertised on something. Not this is not a general AI. This is expert of this system. So these are expert systems. Okay.
Diagnostic systems. Microsoft Office Assistant provides customized help by decision theoretic reasoning about an individual user. Mycin system for diagnosing bacterial infections of the blood and suggesting treatments. Pathfinder medical diagnosis system, which suggests tests and makes diagnoses.
Okay. So this is one area of AI expert systems. Okay. Another area.
Financial decision making. Credit card companies, mortgage companies, banks, and the U.S. government employ AI systems to detect fraud and expedite financial transactions.
I don't know how many there are transactions, but probably billions of transactions are going through these companies, these systems each day. So it is extremely hard to check them by one by real humans. So a financial decision making system can filter through them and bring attention to human experts, the most critical ones or most inspectable ones and such.
Systems often use learning algorithms to construct profiles of customer usage patterns, and then use these profiles to detect unusual patterns and take appropriate action.
Let's say someone hacked your credit card and make a purchase that is very unusual to your profile. Let's say you are living in Mersin and that purchase made from United States or in China. So this financial decision making system should catch that and alert you or alert your bank or who is in charge. Okay. Classification systems.
Put information into one of a fixed set of categories using several sources of information. E.g., financial decision-making systems. NASA developed a system for classifying very faint areas in astronomical images into either stars or galaxies with very high accuracy by learning from human experts' classifications.
So in classification, the number of categories are preset, predetermined. So for example, in NASA case, there are two categories, which are stars or galaxies. Classification systems are usually extremely usually have extremely high accuracy in terms of AI applications because there are finite number of uh, categories, and if you have enough number of data with the current algorithms, you can classify things into those categories with very high accuracy.
Mathematical theorem proving. Use inference methods to prove new theorems.
So some of the applications of AI, mathematical theorem proving, you can use inference methods to prove new theorems, which is very exciting, very difficult also. Natural language understanding.
Google's translation of web pages. Translation of Caterpillar truck manuals into 20 languages. Note: one early system translated the English sentence, "The spirit is willing but the flesh is weak," into the Russian equivalent of, "The vodka is good but the meat is rotten."
As you can see, sometimes Google automatic translations may result very bad. Also, still they are very inferior to the human experts translations.
Applications of AI.
Okay, more applications of AI.
Scheduling and planning. Automatic scheduling for manufacturing. DARPA's DART system used in Desert Storm and Desert Shield operations to plan logistics of people and supplies. American Airlines Rerouting Contingency Planner. European Space Agency planning and scheduling of spacecraft assembly, integration and verification. Robotics and path planning. NASA's rover mission. Biology and medicine. Modeling of cellular functions, analysis of DNA and proteins.
Okay, so how to achieve AI? AI sounds so good, but how to achieve it?
How to achieve AI. How is AI research done? AI research has both theoretical and experimental sides. The experimental side has both basic and applied aspects. There are two main lines of research. One is biological, based on the idea that since humans are intelligent, AI should study humans and imitate their psychology or physiology. The other is phenomenal, based on studying and formalizing common sense facts about the world and the problems that the world presents to the achievement of goals. The two approaches interact to some extent, and both should eventually succeed. It is a race, but both racers seem to be walking. John McCarthy.
So, these are the two main lines of research. And as you can see, one side is aiming to construct system that imitates the humans AI, and the other one is phenomenal, studying, formalizing common sense facts about the world and the problems. It is more like a mathematical formalization. So both of them interact to some extent, and both should eventually succeed, according to John McCarthy. Okay, major branches of AI.
Major branches of AI.
So perspective system, perception. It's about perception.
Perceptive system, a system that approximates the way a human sees, hears, and feels objects.
This is an extremely hard task and extremely important task. When this is perfectly achieved, there will be human robots that does the human jobs. There will be autonomous cars that drives on the roads perfectly safe. Just imagine. This will make an historical leap of the humans in the humans history.
Vision system, capture, store, and manipulate visual images and pictures.
Vision system is a necessity for perceptive system to be successful.
Robotics, mechanical and computer devices that perform tedious tasks with high precision.
So the robotics are necessary to basically manipulate anything physically. Let's say you want to open door, you want to cut something, you want to construct something. Everything depends on robotics. Robotics are already very advanced with high precision for uh, expert systems. For a task that is predetermined, it is extremely working well with high precision. However, if you want to build something that is general use, they are still inferior.
Expert system, stores knowledge and makes inferences. Major branches of AI, 2/3.
Okay, learning system.
Learning system computer changes how it functions or reacts to situations based on feedback.
So this learning system is used in many of the current AI systems, such as we talked about how an AI beaten the experts of Dota 2 game. They used a reinforcement learning system. How we saw that they use it. They run 10,000 years of matching. You see, every time it plays a game, it learns something, and based on that something, it tries to improve its success. It plays against itself simultaneously many times. So it is also same for humans. When we start playing a game, we learn it as we played it from the feedback of our previous playings. It is same for learning systems. They learn as they play in the case of playing games or in other tasks doing that task. Natural language processing, which I am already using for recording this video,
Natural language processing computers understand and react to statements and commands made in a natural language, such as English.
and neural networks. Neural networks are also another major branch of AI at the moment because they work so well if you have enough amount of data.
Neural network computer system that can act like or simulate the functioning of the human brain.
Okay, so some major branches: robotics, vision systems, learning systems, natural language processing, neural networks, and expert systems. AI prehistory. Okay, so philosophy, logic, methods of reasoning, minds as physical system, foundations of learning, language, rationality, mathematics, formal representation and proof of algorithms, computation, undecipherability, interactability, and probability. Actually, many of the current algorithms are founded like 30 years ago, 40 years ago, 50 years ago. However, they are only recently become useful to us. Do you know why? Because only recently we have enough hardware, power, and data to make use of them. Data and power is everything for the AI currently. Okay, physiology, adaptation, phenomena of perception and motor control, experimental techniques, physophysics and etc., knowledge representation, grammar, neuroscience, physical substrate for mental activity, control theory, homeostatic system, stability, simple optimal agent designs. Okay, AI history is giving, you see, it is starting with 1943 as pooling circuit model of brain, ones and zeros, Turing's computing machinery and intelligence, and other things. You see, AI discovers computational complexity, neural network research almost disappeared. Why? Because in those years there weren't enough hardware, power, or data. You see, in 85 and 95, neural network resource popularity because hardware has develops every year significantly. Okay, AI state of the art. So, here let's read it.
Have the following been achieved by AI? World-class chess playing, playing table tennis, cross-country driving, solving mathematical problems, discover and prove mathematical theories, engage in a meaningful conversation, understand spoken language, observe and understand human emotions, express emotions.
So this is done. This is also done. This is still not done. There are cars that can drive through a country. However, I think still no cross-country driving. Solving mathematical problems done. Discover and prove mathematical theories done. Engage in meaningful conversation somewhat. Still pretty inferior. Understand spoken language done. Observe and answer human emotions kind of done. Not fully. Express emotions still kind of done. Okay, special topics and introduction. So these are the topics of AI.
Natural language processing, robotics, machine learning, expert systems, genetic algorithms, information retrieval, planning, vision, neural networks.
Okay, let's take a pause for myself. Okay, let's continue. Natural language processing.
Natural language processing. Process information contained in natural language text. Also known as computational linguistics, CL, human language technology, HLT, natural language engineering, NLE.
Okay, these are the other names of natural language processing.
Can machines understand human language? Define, understand. Understanding is the ultimate goal. However, one doesn't need to fully understand to be useful.
For example, currently, machine is converting this text into the speech. However, it doesn't understand it. It may be understanding to a certain degree to compose voices in a better way, but it doesn't understand as humans do.
Analyze, understand and generate human languages just like humans do. Applying computational techniques to language domain. To explain linguistic theories. To use the theories to build systems that can be of social use. Started off as a branch of artificial intelligence. Borrows from linguistics, psycholinguistics, cognitive science and statistics. Make computers learn our language rather than we learn theirs. The input-output of a NLP system can be written text, speech. To process written text, we need lexical, syntactic, semantic knowledge about the language, discourse information, real-world knowledge. To process spoken language, we need everything required to process written text, plus the challenges of speech recognition and speech synthesis.
Okay, NLP applications.
Question answering. Who is the first Taiwanese president?
So first, it has to convert spoken language into the text. Then it has to uh, analyze this question, understand it, and answer it. It requires so many background processes. This is very hard one. Text categorization routing. This is rather easier one. This is
Text categorization, routing,
rather as
e.g., customer emails.
classification text mining.
Text mining. Find everything that interacts with BRCA1.
Machine assisted translation, for example. Okay, nothing here.
Machine assisted translation, language teaching, learning, usage checking, spelling correction. Is that just dictionary lookup?
Okay. So these are the NLP applications. Let's continue with robotics.
Word robot was coined by a Czech novelist Karel Čapek in a 1920 play titled Rossum's Universal Robots, RUR. Robota in Czech is a word for worker or servant.
So this is the history of robots. Definition of robot.
A robot is a reprogrammable, multifunctional manipulator designed to move material, parts, tools or specialized devices through variable programmed motions for the performance of a variety of tasks. Robot Institute of America, 1979.
So key components: power conversion unit, sensors, actuators, controller, user interface, manipulator, linkage, and base. These are the key components of a robot. Robotics. What can robots do? Industrial robots. Which these industrial robots doesn't require AI to work. Okay, so you need to separate robots and AI. Robots can work perfectly fine without AI, which they have been working for many years now. Because all of these tasks can be programmed without artificial intelligence or machine learning.
Material handling, material transfer, machine loading and or unloading, spot welding, continuous arc welding, spray coating, assembly, inspection.
NLP applications. Okay, we saw that. Oh, this is extra page. I should remove it later. Okay, machine learning.
Machine learning, adapt to, learn from data. To optimize a performance function can be used to extract knowledge from data, learn tasks that are difficult to formalize, create software that improves over time.
So we have seen that there are many subdivisions of artificial intelligence. In this course, we will focus on machine learning. This is one of the primary division of artificial intelligence. It is extremely important, extremely useful, and extremely popular recently. So if you become an expert in machine learning, you can get a job very easily. You can complete many tasks with easiness. It is like an ocean. Okay.
Machine learning is programming computers to optimize a performance criterion using example data or past experience. Learning is used when human expertise does not exist. Navigating on Mars, humans are unable to explain their expertise. Speech recognition, solution changes in time. Routing on a computer network, solution needs to be adapted to particular cases. User biometrics.
Okay. You see, for cases of learning, we can, for example, add playing against humans in Dota 2 game. You can't code infinite number of variables or infinite number of situations. It can only learn and adapt by playing many games and improve its gameplay. So it is also, for example, another case of learning. Machine learning. Okay, there are uh, four different, let's say, methodologies. One methodology is supervised learning. In supervised learning, you provide labeled data. In unsupervised learning, there is data and it learns according to the rules you define. Discrete and continuous. Discrete is classification or categorization. Supervised learning, discrete is clustering. Continuous is regression, and unsupervised continuous is dimensionality reduction. We will have more information about them in the future lessons. Let's continue. Machine learning classification applications. Classification is one of the most used application of machine learning. We use classification in so many areas, and let's look some of them.
Face recognition. Pose, lighting, occlusion, glasses, beard, makeup, hairstyle, character recognition, different handwriting styles. Speech recognition. temporal dependency, use of a dictionary or the syntax of the language, sensor fusion, combine multiple modalities, e.g., visual, lip image, and acoustic for speech, medical diagnosis, from symptoms to illnesses, web advertising, predict if a user clicks on an ad on the internet.
Okay, so in face recognition, how classification is done? If you want to recognize something, you have to have information about it. So face recognition means that computer scans a face and match that face into the one of the people it has in its database. So basically, you classify a picture of face into one of the classes. In this case, classes are humans that are predetermined, preset in that database. So it recognizes that face either belongs to person A or person B or person C. How many among you have? Character recognition. Character recognition, it classifies character into one of the characters in its database. For example, in English characters, it recognizes which character is that character. So it is still classification among a number of determined classes. Speech recognition, same. This time it recognizes which word is being talked. So it classifies words. It classifies sounds into the words that it has in its database. Medical diagnosis. Once again, it classify the illness in one of the illnesses it has among illness classes. Web advertising. This prediction, it means that either it will click or not, or either the click was genuine from a really interested person or it was automated click. So you see there are two classes in these examples. Okay, training of examples of a person. So you see there are four classes in this case, and it trains examples of a person. So we provide these images to the machine, and it builds a model for this person. So when we provide each of these images, that model outputs that this image belongs to this person. So from the trained model, it classify the image into one of the classes it has in its database. Okay, expert systems.
The term expert system is used in a paper by Alan Turing in 1937 related to a study in AI. An expert system, S, is a computer program that reasons using knowledge to solve complex problems. Feigenbaum, 1992. Traditionally, computers solve complex problems by arithmetic calculations, and the knowledge to solve the problem is only known by the human programmer.
Okay, expert systems architectures. There are experts. Of course, to build an expert system, you have to have an expert in that field, because expert will provide knowledge to the acquisition system. So you will get the knowledge from expert and build knowledge base, and then your algorithms, your inference engine explanation system will provide answers to that problem based on the knowledge obtained from experts with the artificial intelligence algorithms or static codings, genetic algorithms.
A class of probabilistic optimization algorithms, inspired by the biological evolution process, originally developed by John Holland, 1975.
So genetic algorithms are branching like this: search techniques, calculus-based techniques. So calculus-based techniques branches into direct methods, indirect methods, and Fibonacci and Newton. Guided random search techniques, enumerative techniques, evolutionary algorithms, simulated annealing, dynamic programming, evolutionary strategies, genetic algorithms, parallel, sequential, centralized, distributed, steady-state, and generational. Genetic algorithms, some genetic algorithm application types. Let's read them. For example, control.
control gas pipeline, pole balancing, missile evasion, pursuit.
And so in these application types, each one you control. You control gas pipeline. What does that mean? That means you uh, let the gas go through the pipes certain amount. You calculate how much you need to provide gas to the system based on perhaps the previous data, pole balancing, missile evasion, how to evade from a missile. You control the direction of your craft or pursuit of a, let's say, an autonomous vehicle design.
Semiconductor layout, aircraft design, keyboard configuration, communication networks.
For example, on semiconductor layout, it is extremely important to use that board efficiently. You have to put conductor lines on that board with maximum efficiency to get the maximum profit, to spend the least amount of resources. So in design, it's extremely important. Scheduling is also another important task. You have to use your available resources with maximum efficiency, such as your cars or your trains.
Manufacturing, facility scheduling, resource allocation.
Robotics, trajectory planning, machine learning,
Designing neural networks, improving classification algorithms, classifier systems.
filter design in signal processing, in game playing, poker, checkers, prisoner's dilemma, combinatorial optimization.
Combinatorial optimization.
Okay.
Set covering, traveling salesman, routing, bin packing, graph coloring and partitioning.
Okay, information retrieval. This is also another important aspect for uh, artificial intelligence goal.
Goal equals find documents relevant to an information need from a large document set.
One of the best example of information retrieval is Google. Google scans all of the web and tries to bring you the most relevant information that you are searching for. So this is the best, perhaps the best example of information retrieval. Okay, possible approaches.
1. String matching linear search in documents, slow, difficult to improve.
2.
2. Indexing asterisk fast, flexible to further improvement.
Okay, indexed-based IR systems, information retrieval systems, document indexing, presentation keywords, and query indexing, query analysis, representation keywords, query evaluation, representation keywords. Indexes are used in every application of big databases. You have to have proper indexes, otherwise you can't access the data efficiently. When you learn database management, you have to learn building proper and efficient indexes. Without indexing, you can't have a big database. You can't manage a database properly. So indexing is used in every area of data. It is same for information retrieval systems as well. Planning, okay.
The task of coming up with a sequence of actions that will achieve a goal is called planning. It contains both how to take actions in the world, the search-based problem-solving agents, and how to represent objects, relations and so on, the logical planning agents. Scheduling plus game playing.
Okay, computer vision. Make computers understand images and video. For example, what kind of ski?
What kind of scene? Where are the cars? How far is the building?
So, a computer vision system should be able to understand and answer each of these questions. Why computer vision matters: safety, health, security, comfort, fun, access. Basically, we need computer vision to have autonomous systems, or to improve our jobs easiness. Okay. Okay, so let's see some of the computer vision applications. Optical character recognition, very popular. For example, our speed radar systems are already using optical character recognition to recognize your car plate, and if you are going with overspeed, they uh, they issue uh, they issue fee to you, so you have to pay that. Or technology to convert current text docs to text. For example, Google uses this a lot for Google Books. For face detection, in this case, it just try to focus on the faces, so determine what is face, how does it look. Neural networks is another massive area of artificial intelligence, and it's also part of machine learning.
A mathematical model to solve engineering problems. Group of highly connected neurons to realize compositions of nonlinear functions.
Yeah, this is important. Non-linear functions, tasks. It is basically used for almost every task.
Tasks, classification, discrimination, estimation.
Okay, there are two types of networks.
Two types of networks: feed-forward neural networks, recurrent neural networks.
Let's have some information about them.
A feed-forward neural network is an artificial neural network wherein connections between the nodes do not form a cycle. As such, it is different from its descendant, recurrent neural networks. The feed-forward neural network was the first and simplest type of artificial neural network devised. In this network, the information moves in only one direction, forward, from the input nodes, through the hidden nodes, if any, and to the output nodes. There are no cycles or loops in the network.
So it gets the data from input layer. In the hidden layers, the data is progressed to other layers, and in the output layer, it produces an output. This is feed-forward neural network. We will see about neural networks in future lessons, and let's have an idea about recurrent neural networks.
Recurrent neural networks.
Okay, let's read it.
A recurrent neural network, RNN, is a class of artificial neural networks where connections between nodes form a directed graph along a temporal sequence. This allows it to exhibit temporal dynamic behavior. Derived from feed-forward neural networks, RNNs can use their internal state memory, to process variable length sequences of inputs. 1, 2, 3, this makes them applicable to tasks such as unsegmented, connected handwriting recognition, 4, or speech recognition. 5, 6, the term, recurrent neural network, is used indiscriminately to refer to two broad classes of networks with a similar general structure, where one is finite impulse and the other is infinite impulse. Both classes of networks exhibit temporal dynamic behavior. 7. A finite impulse recurrent network is a directed acyclic graph that can be unrolled and replaced with a strictly feedforward neural network, while an infinite impulse recurrent network is a directed cyclic graph that cannot be unrolled. Both finite impulse and infinite impulse recurrent networks can have additional stored states, and the storage can be under direct control by the neural network. The storage can also be replaced by another network or graph, if that incorporates time delays or has feedback loops. Such controlled states are referred to as gated state or gated memory, and are part of long short-term memory networks, LSTMs, and gated recurrent units. This is also called feedback neural network, FNN.
Okay, unfolded basic recurrent neural network. So this is how it is. It has a feedback, as you can see, and the almond network, and long short-term memory units. You see, these are pretty advanced stuff. It takes a lot of time to understand them. Let's see if there is a better explanation of this. Okay. Okay, let's open this page. Okay. So input layer, hidden layer, output layer. As you can see, output layer changes the input layer. So there is a backpropagation through time. An algorithm used for updating weights in the recurrent neural network to minimize the error of the network outputs. For every recurrent network, there is a feed-forward network with the identical behavior. Okay, so the network can be trained by backpropagation. This is really important. Why? Uh, For example, you provide a data set with correct labels. So until the system classifies each of these data into the correct labels, it back propagates and updates its weights to improve its accuracy. We will have more information about this in the future, so just have basic idea at the moment. Okay. Okay, for today, this is enough. I will be uploading all of these to our GitHub repository. I will also post on our LMS system of school. Our GitHub repository is this one. I will show you. Uh, let's compose PDF all version also. Oh, okay, there is already PDF version. Okay, I'm just closing this and let's show our GitHub repository. I will be also posting your project on here. I give a semester project for the entire semester. I will also upload that from maybe a few weeks later, not right now. Okay, this is our repository. I'm going to upload latest file. Okay, let's move to uh, okay, this one and say okay. You can come to my room and visit me, ask me your questions. You can email me as shown here. You can ask me any questions you want related to lesson. As an attendance, as a course attendance, I want every one of you to watch entire videos of courses and make an detailed comment about that lesson. I will be posting information related to that. Hopefully see you next week. Stay safe. Try to avoid from crowded places due to COVID-19 outbreak. Hopefully see you next week.